Hi, my name is Joe Blank, and I'm a product manager with Cisco Systems, and I'm here with Georg Cantor to talk about digital reality theory and the implications of that theory on improving science and knowledge. George, introduce yourself.
Okay, I'm Georg Cantor, just recently retired from 35 years with Apple, and I've written several books about digital reality theory. I'm here today to explain it in this video. Now, I want to emphasize we're not knocking science in any sense. What we're trying to do is extend it, modernize it, you might say, by adding a few new features to it. So let's get going. First of all, it has a nickname, DR theory. Unlike many theories, DR theory can be stated in just 7 words. Life understands existence by constructing digital realities. That's the good news. The other news is that 6 of those words need explaining. We'll start with existence. In DR theory, it's everything. The world, the cosmos, me, you, the color blue, the square root of 2, everything. If you can think about it, it exists. Because existence is everything, life is part of existence. Among the ways life is different from the rest of existence is that it understands and constructs. Among its constructions, life creates digital data, which the rest of existence does not. Reality is a part of life that life constructs. It's what we know when we say we know the world. So, DR theory says that life, which is part of existence, understands itself and other parts of existence by knowing a reality of digital data that it constructs inside itself. DR theory applies to all kinds of understanding, both scientific and common sense. In DR theory, the analog data gathered by different ways of knowing are explained and combined by digitizing them and storing the resulting digital data in multiple realities. But there is a problem. There are many ways to digitize data. To paraphrase Kipling, there are 9 and 60 ways to digitize, and all of them are right. For example, ask for a description of a rock from a physicist, a chemist, a geologist, a landscape architect, and a monk who makes Zen rock gardens. You'll get 5 different answers, in effect, 5 different realities. They will overlap in many ways, but some of them may contradict. So why does life bother to digitize its understandings of existence? Because that is essential to evolution. It is not mechanically practical to remember analog data. Evolution is all about life remembering yes-no data, much of which is encoded digitally in DNA. Life would stagnate and die.
What exactly do you mean by digitizing?
Digital data measures existence by counting discrete objects. Analog data measures existence approximately by sensation or estimation. Evolution is driven by trial and error, by whether an organism succeeds or fails. Trial and error is a yes or no process, and therefore it must be remembered digitally. Let's look at a common instance of digitization. It's an eye looking at a red ball. Light reflected from the ball is focused on the eye's retina, which is covered by thousands of tiny receptors. They send signals to a brain using an algorithm that programmers call bit mapping. In the brain, thousands of signals are assembled into a perception set and categorized as a single object. Notice that no light has entered the brain. The brain is processing a digital representation of light. Inside the brain, the object set, the ball, is understood by placing it in category sets: red things, round things, shiny things, and so on. If the brain belongs to a human parent, the object may be further categorized as something to put away, to a child, something to throw, to a dog, something to chase. A scientist may want to know more. A chemist may want to know the exact cross-linkings of polymer strands that give the ball resiliency. A physicist may want to know the structural details of tennis balls, billiard balls, golf balls, and so on. Physicists may even argue about describing the ball in terms of particles or fields. Some scientific arguments start in the process of digitizing itself. The bit mapping that eyes do is only one way to digitize visual data. In computer technology, for example, there are at least three basic ways to digitize an image. Mapping is simple and easy to code, but it can be jaggy and artificial. Drawing is more complex, but it has the advantage that it can change the image size without difficulty. Rendering is the most accurate and versatile, but it requires a lot of processing. Note that the process of digitization is representational, not objective. A woman's face, or a painting of a face, does not contain pixels, or drawing vectors, or Euclidean shapes waiting to be discovered. These digital objects are tools for understanding, not entities in the existence being understood. Programmers realize that a computer never touches a picture directly. It deals only with digitization. If you want a computer to, quote, understand, quote, a picture by analyzing its digital representation, you must take the method of digitization into account. DR theory holds that the same is generally true when scientists try to understand existence. DR theory finds three areas where science could update its foundations to account for digitization. They are evolution, set theory, and digitization itself. In the history of science, evolution was explained in 1859, set theory was launched in 1874, and digitization became understood during the 20th century. All three of these advances should have changed the ways that science creates knowledge, but that has not yet happened. Before 1859, when Darwin published his book about evolution, most scientists had believed that the universe was created about 6,000 years earlier. Biology, the study of life, was eventually updated to account for a history of evolution. However, the fundamental ways that life knew existence were assumed to be constant and not the products of that evolution. Scientific knowledge is supposed to be based on hard facts, not evolving adaptations. Over the years, hard facts in the foundations of science have turned out to be controversial and elusive. DR theory hopes to help by showing that what are assumed to be eternal truths, such as time and space, are actually ancient adaptations coded into human DNA. Set theory was launched in 1874. At first, it was applied only to ideas, but by 1910, logicians had found that it could apply to real things, and in 1920s, it acquired a list of axioms. DR theory uses set theory to show how knowledge can be organized in sets and how different knowledge sets can be related using the power set axiom. I'll say more about that later. Multimedia digitization was unknown before the 1950s. Today, it is everywhere in computer technology. New algorithms for digitizing analog data are developed every year. Digitization is what makes computers useful.
So, George, how does DR theory view the world?
Here is DR's big picture, as simple as I can make it. Existence is everything. We cannot think of anything that does not exist because thinking of it makes it exist. Most existence is non-digital, but within it is a part that is digital. That part is called life. Life is digital because it needs to remember its history. It uses digital techniques such as reproduction by DNA to survive. Life also uses digital techniques to construct discrete objects and combine them to make other objects. Knowledge is a part of life, and therefore it exists and is digital. Life constructs some knowledge by digitizing non-living existence, and more knowledge by combining what it already knows. The results are the realities we know and understand. Finally, because knowledge is digital, it is best understood by set theory, not by mathematics. DR theory examines human digitization in general, regardless of digitizing algorithms, and finds that the resulting realities can be divided into three large sets: behavioral, physical, and ideal. Behavioral reality is our inner world, including personal consciousness and individual memories. Philosophers sometimes call it mind, but behavioral reality also includes our inner feelings and urges. Behavior is the hallmark of being alive. Many people believe that physical reality is all there is. DR theory provides good reasons to believe this is not so. Philosophers have argued about this for 2,000 years and have created equally good arguments that behavior and ideals exist non-physically. Ideal reality is inhabited by the truths of mathematics and logic. We are forced to regard many of these truths as real. For example, finding certain prime numbers is a genuine search for yes and no answers, not a mere exercise in thought. Philosophers have been troubled by the idea of dividing reality into parts because it opens the question of how those parts communicate. In DR theory, existence is one interconnected thing. Reality, which is a representation of existence, is divided among living things, just as living things are themselves divided. Cross-categorization lets us understand reality in different ways. For example, it is normal to evaluate behavior using behavioral categories. But to gain more insight, scientists categorize most animal behavior in terms of physical needs. With humans, scientists also categorize behavior ideally, as satisfying traditions and social norms. In past centuries, scientists have categorized physical events behaviorally, as the work of willful gods or animistic forces. Modern physics began when scientists such as Galileo and Newton realized that physical events could be cross-categorized differently using ideal mathematics. This flexibility of categorization can promote deeper understanding, but it can also cause intractable arguments because it is nearly impossible to compare behavioral, physical, and ideal categories. Here is an example of how a scientific subject might be taught by separating the three kinds of knowledge categorically. One advantage of making such a division is that physical characteristics are mostly specific to individual organisms. Behavioral characteristics usually define species, and most ideal characteristics belong to phyla or other large sections of life.
Where did the division of reality into three big sets come from?
Set theory suggests an answer for that. Physical sets can be treated as power sets of behavioral sets, and ideal sets as power sets of physical sets. If you know set theory, you will understand what I just said. If not, you can find a simple explanation in the current DR theory book. Separating the reality we know from the existence it represents opens the question where time and space belong. DR theory holds that they are ordering algorithms that life evolved, not inherent features of existence. DR theory also adds a cognate form of order, patterns, to supplement time and space. This helps resolve questions such as what happened before time and what lies outside space. Time is the ordering algorithm for behavioral reality sets. DR theory believes that time was life's first major adaptation because it made evolution work. To put it simply, evolution means that later generations of a species are normally better able to cope with existence than earlier ones. For such a process to work, reproduction and death must be at time ordered in each individual organism. Space is the ordering algorithm for physical reality sets. Space may have begun in the DNA molecule, which specifies the time order for building new creatures by the spatial order of codons on genes. Three-dimensional space probably evolved during the time when most life on Earth got energy from photosynthesis. It helped chloroplasts find the sun from the surface of a planet that rotated and orbited in a complex way. Pattern is the ordering algorithm for ideal reality sets. It is the latest of life's general adaptations, and it probably evolved as a result of predation. Predators benefit by recognizing avoidance patterns in prey, while prey benefit by understanding hunting patterns in predators. Not a happy thought, but life is not always nice. In humans, patterns are essential to activities such as the theorizing that produced this video.
George, DR theory looks like a lot to take in. Earlier, you mentioned a book about it.
There are 2 books currently in stores that explain DR theory. They are easy to read, and they cover the gaps in this short talk. This is George Cantor saying thanks for listening.